So, hello everyone. I want to start by thanking the organizers for inviting all of us to this mystery panel, and thank you all for attending when you had the beguiling prospect of exploring Helsinki and you came here. I think you won't be disappointed, because the issues we'll be discussing are very relevant for new investigators and for experienced investigators. The panel you see before you are highly expert and very diverse, representing academic, researchers and mentors, as well as industry-sponsored researchers who have been mentors and investigators as well. We have representatives from funding agencies and from the publishing community. They will be giving their perspectives on issues related to the future of this evolving but still young field, and we'll be exploring some controversies. What we have set up is a three-part session. At first, all of the panelists are going to be asked to give a brief introduction, telling you who they are, what their interest is in computational social science, perhaps how they entered the field, and they will look at what they see as the future. What questions will be available 10 years from now that haven't been addressed yet or can't be addressed yet? I'll start the process myself. I'm Barbara Jasny. I'm a deputy editor at Science Magazine. I've been at Science now for 30 years. I started out as a molecular biologist, but as is true for many editors, my interests grew. I worked on AIDS papers and began to see AIDS networks and the study of AIDS networks. I worked on the Genome Project and saw gene-gene interactions and the beginning efforts of researchers there to look at networks. But it was very clear that the advances in understanding the theories underlying networks and network interactions were most advanced in the social sciences. And as became very clear to me, and as I've communicated to Science Magazine as a whole, the social sciences are as robust and as rigorous as any of the so-called hard sciences, and are exploring questions that are vital to society as a whole. And with that, I will turn it over to Nick.
I'm a physician and a social scientist, a sociologist. I have just two kinds of ideas I want to put on the table. One is I think that there are three different things that are affecting the social sciences in the 21st century, one of which is an obvious focus of our discussions today, and that's the massive passive or so-called big data revolution. But in addition, as I alluded to earlier this morning, I think a biological hurricane is approaching the social sciences. I think that the discoveries in neuroscience, in genomics, and in other similar fields are going to force the social sciences to ask new questions. And I think equally the social sciences are raising questions which are evoking interesting and deep biological questions. I think cooperation is an example of this, and actually networks is an example of this, where a lot of the science of networks was done by sociologists 50 years ago, 30 years ago. Cooperation, ditto, and these now ideas in mathematics are being applied to biological problems. We speak of bacteria cooperating, for example, and that was for a long time a social topic. And finally, as both Matthew and Duncan and others were discussing earlier today, and yesterday, I think that there's a new tradition of experimentation, which was always present in the social sciences, but is being abetted by computational social science. So I think we're going to see a rediscovery and an extensive application of experiments on a small and huge scale in the coming years. And these developments in the social sciences, in my judgment, will be put at best use to three things, and then I'll shut up. One is the deep origins of collective phenomena. So I think that we will increasingly be able to explain and understand collective phenomena. Second is, of course, a question of interest to many sciences is the issue of emergence, which I think is more than a philosophical, but also an empirical question. And last, as Professor Macy yesterday was talking about, is the decline or sort of the uprooting of the atomistic fallacy, which I think is a very powerful development.
This is on. Okay. Hello. I'm Kate Coronges, and I am a behavioral scientist. There should be more of us here, but I began my work in this area looking at how to generate behavioral change in terms of health-related outcomes. And so I became interested in using social networks, real existing, naturally existing networks, to inject information, inject tools, in order to most effectively create behavioral change in sort of real-life settings, field settings. So I went from there to work for the Army, which was a sort of an odd kind of jump for me, and I was able to sort of translate the work that I was doing into thinking about group dynamics. And while the Army does invest a lot of resources in understanding networks in terms of like targeting dynamics, they're also beginning to be interested or becoming interested in using social network analysis and ideas of social computation to think about how to redesign units and understand how teams can be best matched to missions. And it's something that they've never thought about before, and they've used sort of the same hierarchical structure since the beginning of time. And so I began working in that area while I was at West Point, and then soon later took a position again with the Army as a program officer. So I ended up creating solicitations and actually standing up a program in social and cognitive networks. And I work for an organization, Army Research Office, which funds only basic research. So a lot of the job became to educate social scientists how to apply for a grant in basic research. And so sort of unbeknownst to me, I ended up really in this field of computational social sciences, because that's really, you know, how you formalize social interactions. So I kind of fell into that field and really ended up defining it for the Department of Defense, at least for the Army, and ended up taking over a program called Social Informatics, which in many cases when I went to present the program, people said, why are you not calling this social computing? And as I inherited the program, I kind of learned, and I had to learn from the community kind of what these nuances meant. And so as far as where we're going in the future, I think one of the biggest challenges will be kind of bridging the social sciences and the sort of harder sciences, and sort of a theme that I see over and over, and some of the work that I've done has been to kind of identify these sort of phenomenologists, which is what I considered the hard sciences or the physical sciences to be focused or to be characterized, and the social sciences, which is really, you know, social scientists are focused on in what conditions, in what settings, and under what nuanced context do these principles hold. And so I think combining the phenomenologist approach, which is to find universal principles across all social settings, the challenge will be to kind of integrate these two approaches. And so what I see over and over is kind of these threshold effects where we see that in groups of, say, 3 or 10 or 40 or 4,000 or 4 billion, there are different kinds of mechanisms in play. And so to kind of be able to identify these tipping points and these thresholds in our social systems is what I see as kind of the next, the future of the research that's going to be funded and exciting over the years. Thank you.
Thank you. Ivica.
Welcome to everyone. My name is Ivica and I'm here representing the European Commission, but I guess that is visible from my outfit. And I blame Santo for that one, because he sent me a lot of information, but nothing about the dress code. So I used to work for telecommunication industry research for a long time, and I joined the Commission 2 years ago. I'm working for the Future and Emerging Technology Unit as a project officer, but according to the new terminology, it's going to change to program officers because we are shifting from supporting the bunch of projects to supporting a community, cluster, or teams of research. And I'm taking care about a portfolio of FED projects mostly within Framework Program 7. And I have also a couple of projects from the new framework program, Horizon 2020, that is started last year. And besides taking care of projects or monitoring the projects, because the projects have their own coordinator, I'm also participating in preparing the calls, in evaluation the proposals, and helping coordinators to transfer proposals to projects. My interest in social science is twofold. On the higher level, it's due to Horizon 2020 itself, because the integration of social science and humanities is one of the 6 main cross-cutting issues Horizon 2020. And just to take feeling about what the cross-cutting issue is about, it's the other cross-cutting issue is, for example, innovation. That is the most notable one. The other one is ICT. Then gender balance, widening participation, and international cooperation. And on the operational level, I'm also following the Global System Science team. The Global System Science is the Commission abbreviation for, or a mixture for mixture of complexity science or complex system science and this contribution to policy. So the complexity science should somehow help policymakers in tackling the societal global challenges like climate changes, like transportation, like pandemics, like city growth and urbanism, and like, for example, financial crisis also. And my expectation for future is a real integration of social science and humanities into Commission's, into Horizon 2020 projects, programs, and policies, of course, at the very end.
I'm Lada Adamic. I'm a computational social scientist at Facebook. I'm one of, I think there are 3 of us here. Bogdan is a sociologist. Alex Pesakovic is a behavioral economist. I'm a recovering physicist. And at Facebook, we work very closely with computer scientists, with people who have backgrounds in finance, in math, all sorts of different fields. So while one of the aims of computational social science is often to bring people from different disciplines together, at Facebook that's very much already happening with the open office floor plan. You know, there's really no separation walls or anything else. So we're just free to collaborate, which is why I think industry is a great place to advance the field. But when we think about research, there are kind of different, I like to think about different types of research that we can pursue. So because of the richness and the scale of the data, we have interesting challenges, but also interesting opportunities. So Sinan mentioned some of the work by Dean Eccles and Eitan Bakshi and others on causal inference. Once the data is rich enough, you can actually do a lot of causal inference in addition to experiments. Also, Michael Macy had mentioned the limitation of when you look at individuals and you don't get the full picture, you don't know what factors such as social influence are at play. Well, if you have the social network, you can actually quantify network effects. But just the methodology for this is very challenging to develop, and that's what a lot of Facebook data scientists are working on. The second kind of grouping in my mind is because Facebook is connecting so much of the world, it's an opportunity and I think also an obligation to study how this is affecting how we interact with one another. So on Thursday, I'll be presenting a paper where we study news exposure. So when you receive news through your Facebook newsfeed, that is the news that your friends shared, what is the composition? Are you exposed to cross-cutting content? So I think it is important to understand, that we're connected in this sense. What does this mean for us, and how are social relationships evolving? The last component perhaps is most relevant to this audience, and that is how can Facebook contribute to generalizable knowledge, to fundamental social science? And there, I think the future is unclear. We have started some studies, for example, migration patterns is something that's, you can do with Facebook data that might be valuable to the broader academic community. Another thing, so Alex is going to talk on Thursday about predicting cultural trends using Facebook data. But as far as I know, there's no one just studying cultural trends, period, which could be like a very rich research area. And the way that we have collaborated with academics in the past, or continue to do so, it's a good avenue is actually through internships. So if you have very talented students, or if you're, okay, sorry, I'll, I won't try to recruit right here. But it doesn't scale, right? So I think an interesting question is, how can the value that's stored or that's accessible at Facebook, how can that be made accessible in some form? I don't know what that form would be, to the academic community, and then what can we do with that knowledge?
Okay, hello, I'm Patrick Goymer. I'm a senior editor at Nature. I've been there for about 10 years. Before that, my own research was at the sort of intersection between evolution, ecology, genetics and behaviour, I guess, which probably explains my dress code relative to everybody else's. My primary job at Nature is handling research manuscripts, and I do that in a variety of areas. Like Barbara, I've expanded since I've been there. So computational social science is one of those, but I also handle manuscripts in ecology, evolution, agriculture, sustainability, economics, those sorts of areas. I thought it would be useful to sort of couch this introduction in terms of two questions I've been asked since I've been here yesterday. The first of them was, what on earth is an editor of Nature doing here? Are you really interested in this stuff? And I guess the short answer is yes, we're absolutely open for business in this area. But the longer answer probably requires a little bit of historical context. Nature, as you know, is a very prominent science journal, and our mission statement mentions being the fact that we consider topics right across science, and by that most people have usually interpreted that as meaning the natural sciences. And for years that was fine, it didn't really matter. Everybody knew what belonged in Nature and what didn't. Science was science, it was in there. Traditional social science, humanities, arts, literature, they were not, and nobody questioned it. But in the last decade or so, things have got a lot more murky. Areas like computational social science, I guess econophysics, bibliometrics, philolinguistics, those sorts of areas have come up, and it's made things a lot harder, and we've had to do a bit more head scratching about what does belong in Nature. There's no hard and fast answer, but my personal approach is a very inclusive one. If you define science as being something along the lines of an empirical and quantitative reasoning about the world, then all of this, there's nothing that's at this conference that it doesn't belong potentially in the pages of Nature. That's probably a statement I shouldn't have made, potentially. But that's the kind of negative reason why we're interested, that it's in scope. The positive reason is that this is a hugely exciting field, and a relatively new field that's in its growth phase. There are huge new data sets opening up. And some of this data is not just new that we couldn't have had 5 to 10 years ago, it was inconceivable 5 to 10 years ago. And the field is bringing together people from a whole range of more traditional disciplines in physics, biology, and social science, and that makes it exciting. And it also speaks to a lot of the major global challenges. I mean, a lot of the research in computational social science is about how we can live in a healthy, happy, sustainable world, how our economies, our politics, our trade, and our friendships should and could work, and fundamentally how and why we behave the way we do. So those are the sorts of major questions that I see as being interesting in this area. The second, so nature is very much open for business here. The second question that I was asked was, how on earth does nature work? To us, it seems about as opaque as MI5. And this sort of I hear this sort of thing a lot, and it does sadden me a bit, because beyond, if you exclude information about specific manuscripts and about referee identities, there's a hell of a lot of tough stuff that I can tell you guys that I'd love to tell you guys without even having to kill you afterwards. And so I'm hoping in this sort of panel session afterwards, feel free to ask as many questions about the internal workings of nature and presumably science as you'd like.
Yes, I would add, Santo has suggested that it would be inappropriate to kill the audience afterwards. Please do bear that in mind.
Is that all of them or just specific?
Duncan.
Yeah, so I've been trying to, I apologize for coming in late, I've been trying to infer the question that you asked from the answers that have been given.
Basically, can you introduce yourself to the audience, discuss what brought you into this area, and what you see as the opportunities? What questions will we be asking in the next 10 years that we haven't yet asked?
Okay. So I gave a talk yesterday, so you have some idea of what I'm working on currently. But I think, that maybe it's relevant to mention that the kind of work that I was talking about yesterday is very different from the kind of work that I started off doing about 17 years ago now. And back then at Cornell in the mid-1990s, I was actually interested in many of the same questions that I'm interested in. I've always been interested in, collective behavior of humans. But, of course, back in the late 1990s, there was very little data available for those sorts of questions. If you wanted to ask questions about the sort of collective behavior of hundreds or thousands or millions of people, that was something that was not only impossible, but actually inconceivable. And it certainly was inconceivable to me because I tried to conceive of it, and I thought, no, that will never happen. We'll never have the ability to map out the network connections of 1 billion people. Right? Of course, today we call that Facebook, and we can do many of the things empirically that once we had to do theoretically. So when I started off thinking about these sorts of questions, that we were very much in a state where we had to rely on simple mathematical models and computer simulations to try to guide our intuition for how these sorts of phenomena might play out. And then, I went to teach in a sociology department at Columbia for several years, and somewhere in the middle of that, around about 2006, I sort of had this dawning realization that the world was really changing, and it was changing because of things that were sort of outside the realm of science. New companies like Facebook were starting that were creating whole new sources of data that were of a type and a scale that were completely unprecedented. And it occurred to me about then that sociology, whether it liked it or not, was becoming a computational field, and that this was something that computer scientists would have to be involved with, because we didn't internally have the sort of the depth and the breadth of knowledge to own all of these questions ourselves. And so that it was already clear to me that there was sort of an interdisciplinary feature kind of baked into the future of social science. But even back not that long ago at Columbia, it was very difficult to reach out across the disciplinary boundaries within a university. And so I ended up leaving and going to Yahoo Research, where I worked mostly with computer scientists, and have continued to do that at Microsoft. And so over the years, it has become increasingly clear that the computational nature of of social science is really here to stay and is increasingly important. And so, so that sort of, and my work has changed along with it. So sort of, I don't do very much modeling these days. I do a lot more work with statistical analysis of large data sets that we collect from various platforms that already exist in the world. And then, as I described yesterday, we're also increasingly trying to use the web to create our own data sets by going out and running experiments. And so, looking forward, what do I think we should be keeping our eyes on in terms of things to expect and also to try to push for? I think something that Sinan said earlier this morning is very important, which is this notion that preceding revolutions in science are revolutions in instrumentation. And I think that over and over again, I am struck by this realization that if you build the right instruments and you gather the right data, then you're sort of 3/4 of a way to getting the answers to questions. That sure, there are methodological challenges and it's difficult to deal with these large data sets, but the biggest difficulties I think that we face now as a field are not inadequate computing resources or even sort of limitations in our inference methods. But just the fact that we don't have the right data to begin with. We have lots of data, and some of it's very interesting, but much of it is very siloed. Much of it is owned by different entities. So if you just think about, I'm interested in how people influence each other or how their purchasing decisions influence each other. The network information is over in Facebook. The purchasing information is over in Amazon. And yet there's sort of no existing means to join these sorts of data sets together. And maybe you don't want to do that. Maybe that's frightening to you to think that it's already, companies are collecting too much data and we don't want to do that kind of joining. But I think these are the sorts of questions we need to be asking ourselves. And also we might need to think even more broadly and not just, how do we join data from different existing platforms, but as social scientists, maybe nobody is designing their data collection platforms to answer the kinds of questions that we're interested in, and we may need to go out and build our own instrumentation, and that is very expensive and it's very time-consuming, but it may be the kind of investment that we need to undertake as a community if we're going to answer the kinds of questions that are of most interest to us. So I think there's sort of thinking about the acquisition of new types of data, joining existing data in ways that are more useful, and then how do we share things, how do we secure things, how do we sort of deal with all of these questions that will open up the ability of other researchers or increase the ability of other researchers to ask questions of data. I think that as a community, these are very important tasks for us to set for ourselves.
Thank you. So that was part one. In part two, I will be asking the panel some questions that hopefully will get everyone's juices flowing, and then moving into part three, which will leave enough time for questions from the audience. So the first question that I have: computational social science is certainly an interdisciplinary field, different in some ways from the more traditional ones. What are the ramifications of this for young people who are trying to advance their careers? And let me start out with Nick, if you would approach this.
All right, so let me just say a couple things about that. I'm going to just look at my watch and make sure I don't blabber on too long. So the first thing I would say is that as far as I'm concerned, I think everyone in this audience would agree, the most interesting science is typically done at the intersection of fields. And I think it's people borrowing ideas from one area and applying it to a new area. And I think the kind of enthusiasm that I see at young people who embrace this idea there's a saying, it's a terrible thing to raise a man or a woman to a high height only to let them fall. we recruit these brilliant young people with heterogeneous skills who come with skills in computer science and acquire skills in genomics, or who have skills in the social sciences and acquire skills in mathematics. And we imbue them with this fire that there's this incredibly new, interesting stuff that they can do. And then when they're done with their degrees or done with their postdocs, we have nowhere to send them. And it is depressing the hell out of me. Not only when I'm advocating for people to be hired at the universities that I've been affiliated with, or when I have brilliant students that I'm trying to place. And I know many people in this audience have had a vision or have had some experience with this problem. I don't have any great solutions to this problem. I think a lot of it has to do with at least in the United States, with the organization of American universities. We still in the 21st century have an organization we inherited from 19th century Germany. You know, we have sort of a departmental structure that's organized around fields. I think the natural sciences are a little bit better at matching administrative arrangements to where the scientific frontier is. And the reason this is important is that as there are new scientific discoveries, you no longer have departments of botany or zoology or entomology. You no longer even have the departments when I was in medical school of physiology, anatomy, biochemistry, histology. Those are all gone, right? We have molecular biophysics. We have cellular neuroanatomy. We have completely different departments. And it's not just nomenclature that's changed in the natural sciences. I think that their administrative organization reflects where the scientific frontier is, and that in turn creates new opportunities for the young people that are coming up. Whereas in the social sciences, you produce these people and they're neither fish nor fowl. Where do they go if they're at the intersection of behavior genetics and sociology? Where do they go if they're at the intersection of physics and economics? The physicists say they're not us, the economists say, well, they're not us, and so where do they go? And I think that for that to change, I think that there's going to have to begin to be a bit of a breakdown in the way American universities, and I'm assuming elsewhere in the world as well, from what I know, are organized. And I think one model for that is the kind of University of Chicago committee system. So at University of Chicago, you know, they have these departments, but they also have cross-cutting committees, and for example, the Committee on Human Development or whatever, but what those committees have, which is crucial, is appointive power, the ability to actually hire faculty. And I think that's one way forward. If we begin to have departments and other organizations within universities with this kind of appointed power, let's say in computational social science. So I'm just looking at my notes here to see if there's anything else that I want to say. Oh, say a couple more things. One, I've watched initially with alarm and now with admiration what's happening in industry with respect to hiring academics and some of the brightest people. I think these things come and go in waves. I think we're at a wave right now where some of the most talented individuals are finding it extremely appealing to work outside of academia and work in industry. And it's no surprise to me. There's data, money, and an environment in which people can publish and interact with each other in these very ways that have low walls. So I'm increasingly seeing people leaving academia right out of their PhD programs in a way that to me feels very different. I don't know what Michael would and others would think than it used to years ago. And I think I've now been speaking for 4 minutes. I'll say one more thing and then I'll stop. I think that when I advise young people about what to do, it kills me to put a wet blanket on them, so I don't. I say, you know, you can have that fire, you can have that enthusiasm, you can have that idea of, oh my God, look at this cool thing that I'm onto and that I'm working on, but, you know, hedge your bets just a little. And so I tend to advise people to have an additional project that's very doctrinaire, that can very squarely fit within some discipline. In my current position, I'm the executive director of the new Network Science Institute at Northeastern, and this is the second year of a PhD program there in network science, and this is, you know, we're dealing with many of the issues that come up from training people in interdisciplinary sciences, and so far I've sort of been exposed to some of the internal diplomacy that needs to take place across the colleges and a lot of the hiring issues that occur, as Nicholas mentioned.
all of our, all of the people that come into our institute have to be hired within departments. And so now we're training this sort of next generation of network scientists. And, I don't have any great wisdom on this, but my story on this is that when I met with one of the main leaders in this institute, and he's not here right now, so I can tell the story. He was telling me that he's meeting with a lot of prospective candidates, and how he's encouraging them that this is the frontier, and they're going to be exposed to things their peers are not. They're going to have interdisciplinary skills and knowledge that their peers will not have. But then he sort of leaned over privately and said, and this is how private it is between all of us and YouTube, that he said, well, if it were my daughter, I probably would tell her not to do it. So there is this sort of case of, not in my house kind of thing. And so I think that part of it is some of the future will change in part by institutions taking some risks in this, which Northeastern University has done. And another part will change as a result over time by supervisors and dissertation chairs saying, this might not be, the best thing for you to get the best job out of here, but, don't hold back your kids, nurture your kids to go on and do something innovative and exciting, and I think that that's what will create change over time. So.
I'm so thankful, Barbara, on this question, because this is a seldom opportunity that shows that public administration is not of the tail of events. Because for future emerging technology, calls the interdisciplinarity is mandatory, full stop. So.
I guess
You don't have to, if you don't have burning comments, we can move to another question. I don't want to,
okay,
I don't want you to feel we're going to keep moving down on the line, but Lada, I see
okay,
you
yes, I
something.
fully agree with Nick that
Go ahead.
industry is a wonderful option, but I think academia is as well. I've perceived things being more flexible, both for going between departments. So my PhD was in physics, but I was faculty at a school of information. Like, schools of information are great. They'll take anyone. And the PhD students coming out of those programs, I think, at least at Michigan, where I was, they placed extremely well. So I didn't see that much of a crisis there, but that could be kind of that particular boundary.
Yeah, okay, I just wanted to say a little bit from the publishing perspective. Most of what you guys have said has been rather doom and gloom. And there are two sides of it in publishing, but one thing that being an interdisciplinary science actually allows is it actually probably provides more opportunity to publish in some of the highest impact journals than some of the things that are siloed into specific fields. And when I go to ecology conferences, I get the complaint, well, I've spent 25 years studying every aspect of the ecology of this lake, and then somebody comes along and spends a few hours on Facebook and you publish their paper. I mean, that's a little bit of an exaggeration, but in some ways, this interdisciplinarity is an advantage. How that then translates through to hiring is a different matter in universities. Somewhere on the other side of the coin in publishing, it does mean there aren't established subject journals in some areas, but the publishing landscape in the last 5 years has actually been able to adapt far quicker in introducing new titles than it maybe did 10, 15 years ago. So I don't think that's as much of a concern. So that's all.
So I think the, I agree with Nicholas that nothing stifles a young person's creative spark quite like the dean coming to them at the start of their appointment and saying, here is a list of the 5 journals that you must publish in order to get tenure. And if you think that this doesn't happen anymore, think again. It absolutely, Sanada's nodding his head because that happened to him when he got to NYU, and it happens to people even today. And it really puts a very serious constraint, a debilitating constraint on the kind of work that you can publish or that you can even think about working on if it has to conform sort of the fairly narrow conception of what counts in the sort of 3 or 4 top journals in a particular field. And I think, solving that problem is sort of the key to getting interdisciplinary research off the ground. But in some ways, this just begs the question because, how do you solve that problem, right? That's sort of how many departments are organized. And I don't have, good answers for that question, but there are some hints of what it could look like otherwise. And I certainly, one of the things that so one of my colleagues a couple of years ago made this sort of interesting observation about the difference between Microsoft Research and a traditional academic department. And he said that, in an academic department, you have a bunch of people who have very similar training who are all interested in different things. And at Microsoft Research, you have a bunch of people with very different training who are all interested in the same things. And the way that translates into career incentives is that, we are still very much rewarded in a traditional academic way by the publications that we produce, and our managers are very concerned about the status of those publications, that publishing in top journals is still very valued, or top journals and conferences. But the key is that they don't care which field you publish in. So if you publish in a top computer science conference, that's great. If you publish in Nature and Science, that's great. If you publish in the American Journal of Sociology, that's great. And just shifting from, here are 3 journals that you must publish in order to get tenure, to publish in any good journal and we'll be happy with that, enormously increases the freedom that you have to think about what's an interesting problem to work on, rather than what is something that will get me published in this particular journal. And so I think, the larger point is that if we try to reorient ourselves from, sort of journal publications as the, or particular journal publications as the measure of career progress, to solving problems as the measure of career progress, then that, I think, is the wedge that we can use as a new field to make an impact and to generate public interest and institutional support, to say, look, computational social science, here is a problem that we have solved, right? And this is something that was not known in any traditional field, and the way we solved it was by bringing together these diverse approaches. And then I think, you've got a story that people can get behind.
Barbara, can I just butt in for one little bit in response to that about the problem with several journals having this prestige, and obviously at Nature it's something we are very aware of this problem, and we certainly do not want to encourage it. And a lot of the problem comes down, and I'm sure Barbara will agree, to the power that impact factors have. And interestingly, this field, and Laszlo talked about it this morning, is there are, this is a field where you guys can actually come up with alternative metrics that possibly better rate the importance of individual studies, individual papers. So that's a sort of a challenge.
I also wanted to say something more about publishing interdisciplinary papers. While no one would disagree that peer review has its problems, one of the things that it can do very well is handle the challenge of interdisciplinary papers by having multiple reviewers who represent different facets of a publication. And at Science, we have a cross-review process after peer review so that the reviewers can basically see each other's review, comment on it, but be looking at a paper from their own particular perspectives, so that interdisciplinary papers are exciting and are becoming more and more commonplace within the magazine and are the way the field is going. So we see ourselves as meeting that challenge. Let me move on. Ivica, a question I've been told a lot of people will be interested in. Do you foresee dedicated calls or funding programs on computational social science?
I already mentioned that social science is one of the main cross-cutting issues, Horizon 2020, and there is also, because as you probably know, the Horizon 2020 is divided in 3 parts, 3 main parts. It's industrial leadership, societal challenges, and excellent science. And within societal challenges, there is challenge number 6, I think. And it's inclusive, innovative, and reflective Europe in a changing world. That is like a place or for dedicated topics to social sciences. Mm-hmm. And apart from that, there is also social science because it's a cross-cutting issue, and when we're preparing the work program, our main documents, that we base funding on that, and that is the 2 years documents. We are obliged to take into account as much as possible. It depends, of course, on the field. To integrate social perspective in all. For example, the future emerging technology is part of excellent science, and it's one of the 4 objectives in global system science last call. So it must be it must be included inside it. So there is, just roughly speaking, there is about 150 topics somehow related to social sciences in the first 2 years of the horizon. And if we transfer that in money, so the whole horizon in 7 years is about 75 billion of euros. And if you, for example, 20% of topics transfer in money, it's about 4.3 billions of euro in the first in the whole horizon in the first 2 years, somehow related to social science and humanities, because this social science and humanities is coming always together, but is some kind divided between these two fields.
Thank you. Somewhat related, Kate, let me ask you as a funder, how would you develop a portfolio that works well in this interdisciplinary area?
So first, just in reference to your last question, I think that something that, I was involved for a short period of time in creating these solicitations within the Department of Defense in the US. And one thing that you learn being a program officer is that most people funding these programs are, well, I should say much of the time, they don't have a background in the field that they're funding. So people move around the government jobs a lot, and they're not hired because they're experts in the field. So a lot of what I learned is that you have to, the people who are successful in getting grants already know this, that a lot of the funding process is by communicating with the program officer. So it may not be called computational social sciences or the field that you're looking to be published in, or to get a grant in, but a lot of the times the solicitation could easily be interpreted as such. So a lot of it is to educate your program officer by talking to them and telling them about your work and how it applies to the call that they're putting out there. So I think some of the younger people I've found don't know that, and as a program officer, I've sort of had to train them, hey, you need to teach me, and then we can work together and find sort of a common language that meets both of our needs. And in regards to putting together a successful program in this area, one of the things that I did as a program officer is have these strategy meetings. And so when I took over the social informatics program, I felt very much like how I just described, as someone who really didn't know the field, because it was within the computer science department or division in the granting agency that I worked for. So what I do in that role is I listen, and I try to learn what is exciting in the field, what's being done in the field, what people are abuzz about. And so my sense for what could be a good portfolio in this area kind of has these two distinct areas of sort of computer scientists and social science approaches. And for the computer scientists, well, I'll say for the social scientists, I think one of the contributions that they have to make in this area is to define sort of a set of metrics and quantifiable models to think about these social processes in this like technology-based interfaces. which we tend to think of as big data, but it's all of these different mediums that we are interacting within, which don't necessarily have the same metrics that we've been using in the social sciences. For instance, people's persona in their electronic world may be very different than their one in face-to-face. So the issues about perception and interpretation of information that comes to you through those devices, trust, deceit through those mechanisms, these intentional deceitful messages that come through those medium, how we influence, how we intervene in behaviors, all of these things probably have very different mechanisms. So it's the social scientist's job to kind of define those things. The other another major issue is tie strength. I mean, how quantifiable is tie strength? It's sort of, in much of the work that I see here and in this field, there's this assumption, we generally just assume 0, 1, and if it's weighted, it's something about, email frequency or something. But, how can you really define a tie strength and think about those, really those issues that have taken social scientists many years to formulate? And take anthropologists and ethnographers and things to think about. So I think that is a very fundable area. Developing a set of theories and algorithms that do hold true in these settings, but may not hold true in a face-to-face environment, and vice versa. So we generally lean on things like social learning theory, group formation theories, identity, collective action. So to develop a set of theories that hold true in this environment would be important. And from the computer science end, I think that one of the areas that we really don't know about is sampling. And so we've sort of hinted on that in this panel already, but we know we have a lot of data, but we don't really know much about what that data, how generalizable that data is. So we need to have studies on sampling and probing and understanding how we can collect data that's relevant to the problem that we're interested in. And then ultimately kind of thinking about whether these issues of these different processes of social exchange and social influence what are the limitations of big data for those kinds of questions. So are you really detecting emotional influence? There has to be some limitations here. So kind of defining and delineating the limitations of the kinds of questions we can ask in these settings, I think would be important to kind of address.
Thank you. Let me turn to a somewhat different topic. It's been said by some that the most valuable data sets for asking complex, societally relevant questions are proprietary or have associated privacy concerns. Yet the computational social science community as a whole, like other research communities, is striving for greater transparency in order to promote reproducibility. How can these two forces be reconciled? And maybe, Lada, I can toss that in your direction.
Even though I had a lot of lead time with this question, I did not come up with the magical solution to this problem. You're absolutely correct that the number one concern is privacy, right? We're dealing with data that is sensitive, and reproducibility is great. If data sharing just meant that someone was going to reproduce the results, that's great. But frequently, what makes data sharing really wonderful is that someone's not just going to reproduce the results, but also do additional analyses. And some of those additional analyses can put the privacy at jeopardy. So we had the very well-intentioned release of AOL search logs where some individuals were re-identified because we all have like very unique signatures. And so there's also, academic research. Lars Backstrom and John Kleinberg showed that it's impossible to actually anonymize social network data. We know that geolocation data is also very specific. And so that's all very discouraging, right? These are reasons why such data could never be shared. On the other hand, these problems are not entirely new. So people have been doing research with census data, which is also very sensitive. And there are solutions such as, for example, creating simulated data sets that have the characteristics of the actual data, but are, have enough randomness that you could not identify any individual there. Is Facebook investing in creating such simulated data sets at the moment? No, but I think it's something that could be done in collaboration. I mean, we're definitely interested in seeing how we can assist the community in reproducing results. We appreciate pressure from editors for finding some middle ground, some data, not the raw data, but some intermediate data that does not pose any privacy risks, but that can still allow other researchers to reproduce the results. So I think it's a frontier, and I hope we'll all work on it together.
So I think that I think it's important for people in the academic world to understand that people working inside corporations are generally also nice people and that within any one of these companies there's usually a cadre of people who are actually very sympathetic to the idea of public release of data and of using the data for the public good, right, and for scientific progress. So I think there's a lot of goodwill, at least in principle, right. The problem is that the lawyers get involved, and the lawyers point out that essentially it's all downside risk for the company, that there's, as Lada mentioned, there's serious privacy implications, and I think the AOL debacle of about 7 or 8 years ago really chilled any incipient...
well, there was Netflix, and that didn't end well either. Right,
yes. Right, but I joined Yahoo right after the AOL thing happened, and that just put the brakes on anything that was in the works. So there's clear privacy implications. There's also intellectual property implications, and so I think what happens is that people are interested in doing it, are sympathetic to the proposal, but then everything is dominated by the downside risk, and so we have to think: how do we limit as a field, as a community? How do we find ways and mechanisms to limit the downside risk that is faced by these private corporations in sharing their data? And so, Lada mentioned the Census Bureau. I mean, the Census Bureau is an interesting model because they have these secure data centers that you have to apply to if you want to use their data. You have to write a proposal. They're extremely sensitive about bringing in. You can't bring in any kind of storage media. You have to do all your research inside the data center. So there are sort of models for handling sensitive data. We have HIPAA. We have AdHealth. There are sort of interesting ideas out there for how we might develop new institutions and organizations that are specifically designed to help companies make their data available to the scientific community. But that's work that I think we would have to do as a scientific community. You can't expect that any individual company is going to unilaterally make that sort of investment. So I'd say that's one approach that we could try to pursue. And the other approach is to generate publicly available data ourselves, right? To say, well, maybe Facebook is not the solution, right? Maybe we should stop thinking about how to make Facebook data available to the scientific community and just create our own instrumentation and build our own platforms that generate the data that we are most interested in. And that's probably not possible on the scale of Facebook, but maybe there are lots of interesting questions that we can answer that don't require us to have 1 billion people, or whatever it is now, 1.5 billion people signed up. So I think that is another alternative strategy. Note that both of these strategies require investment. So we need infrastructure, we need institutional support, we need people who are working on this full time, and so I think behind both of these strategies is a sort of meta goal of convincing the public and the funding agencies that these sorts of investments, which are substantial, are worth the scientific payoff.
Thank you. Yes.
I want to say something on this issue. Okay, thanks. We are running the pilot on open research data. And for some selected fields of Horizon 2020, this is like a mandatory, but if you really justify, you can opt out from this program. But we are trying really to make this, because there is the very, very understandable rationale behind that is like a public money, public data. So we are really trying to make, for research publications, we already did that, and we are really trying to make that for research data. But I also want to share with you some anecdotal saying from one university in Switzerland, and I won't tell which one. So the saying says, one set of data, one paper, two set of data, no paper. So it's very hard to deal with this abundance of data. So.
Is that something that can you tell us a little more about that? I wasn't sure I understood completely. That there are data sets that haven't been exploited? Is that what?
No, it's more about like the reason why some institutions are not willing to publish data, because it's very hard to if you take all data in account, it's very hard something to prove your hypothesis. So if you have too much data, it's not possible to prove your hypothesis.
I see. So. Thank you. Well, I wanted to make sure to allow sufficient time for the audience to ask questions. We may come back to the panel a little bit later, but I hope you have stored up your questions, and please, there are people with microphones. Please do use them, and please identify yourself when you ask.
It's more a comment than a question. I just want to balance some of the things out. About 5 years ago, the situation was a little bit what Nicolas described, at least with my lab, is that people would graduate and they would have to masquerade as disciplinary scientists to get a job. I think that has changed significantly in the last 5 years, and that has changed partly because of the major cluster hires that are happening, at least in the United States, where the universities are giving out big piles of money and departments need to find actually for people that are appropriate within that subject. And we see the big data wave sweeping through the American universities. We see actually aspects of data-driven cultural studies and social sciences and specific programs coming up and institutes and centers coming up, and they're driving really the hiring. And I see more and more of my people, or the people I know in the community, being swept up by those things and being hired for what they are, interdisciplinary scientists rather than disciplinary. Often the departments from where they originally came from arguing for their hire because they feel they are interdisciplinary, they satisfy the needs of the university, and they are us as well.
Mm-hmm. Thank you. I think behind you, yes.
Okay.
You have, yes.
Push the button or not. Can you hear me?
Yep.
Yeah. All right. Georgi Bobashov from RTI International. And I actually have 2 comments and a question. So one comment is about hiring. For example, so I represent kind of like industry that does contract research. So our clients are governments and private industry. And we would like to collaborate with academia as much as we can, but we are slightly differently evaluated. So yes, publications are a big part of our evaluation, but the main evaluation is actually what kind of impact do we have on community, on the society, and what kind of problems are we solving for real world. So from this perspective, we're trying to figure out how to collaborate with universities. Because, for example, we are hiring data scientists. We are trying, and we are struggling. We cannot find people who would be interested in doing social science and computer science at the same time. We know they are somewhere at the universities, but we don't know where to find them. We have job announcements in so many places, and we only get, 1 or 2 hits. So what I hear is that, there are people who are willing to do this work and who are looking for very interesting projects, but perhaps we need to figure out how we can bridge this gap. Another side is that, for example, several years ago, we have created a resource which is a synthetic population, which is virtual census. So we represent every single person in the United States, but the data is slightly scrambled, so the marginal distributions and the joint distributions are the same at the block group level, but you essentially get...
Can I ask you if there is a question?
And the question is, how can we, what will be the mechanisms? How can we build these relationships? Because what we see the problem that industry is working within themselves and academia is working within themselves. And we don't see many people coming to the conferences that we attend, and we don't attend very much conferences that where are you going.
So would anyone like to take this up on the panel?
I mean, clearly they should come to this conference.
That's a good answer.
I think to respond to both of those comments, that it's true that things are a lot better now than they were, certainly when I was a postdoc. So yeah, there have been interesting changes, but I think that there are still some there's a lot of resistance in traditional academic fields. Certainly, places like Facebook and Microsoft, we have, very active programs in summer interns where we recruit students from top departments, either in traditionally in computer science, but increasingly also in the social sciences, that is a sort of a gateway to other kinds of jobs that whether faculty jobs or even or data scientist jobs. So I think that we're certainly trying to act as this broker between the academic world and the industrial world. But I think the other thing is that it's sort of an educational process to sort of help faculty realize that there are interesting, intellectually challenging, research-oriented jobs that are not in traditional, that don't have traditional labels. That there is a huge demand, I know, in the private sector for data scientists who have a sort of a sophisticated understanding of causal inference and are good at asking questions and have sort of theoretical backgrounds. But you're probably right that many people who are training graduate students these days are unaware that those jobs exist. So I think that some sort of outreach and education is probably helpful there.
Next question. Here, I see the microphone.
Thank you. Omar Guerrero from Oxford. Thank you very much for the insights, especially all the discussion about the problems that we have as interdisciplinary scientists to find jobs in the private sector or academics. And I think that I am missing an important sector here, which has to do with probably the place where social scientists have most impact, which has to do with policy. And I'm talking about ministries, think tanks, international organizations, central banks. And from my experience of approaching these type of organizations, you find a very well mixed ecology. There is people who is quite open to these approaches, but they don't really know what to do about them, so they tend to be quite careful about hiring people like us. and other places are just as conservative as the most traditional academic departments. So I would like to hear if you have any thoughts on how to bridging, like closing this gap with regulators, policymakers. How can they start demanding our skills?
Mm-hmm.
Okay, I have just one example. For example, we are just when prepared the call for this complex system science, we just put in the code that it's mandatory to solve some or to work on some real world problem. And it's amazing that in proposals, for almost every proposals, at the end we found that some letter of support from such kind, from local government, for ministries, for NGOs. So that is really, I've seen that people that is really working on this interdisciplinary project really knows how to include all this organization. But you have completely right. Such inclusion of this stakeholder in social sciences dealing with policy making is extremely important, for sure.
I would add to that, the American Association for the Advancement of Science, which publishes Science Magazine, has a system and a program for AAAS fellows, who are individuals from a variety of fields who are willing to be placed in congressional offices, in various NGOs, and who will interact and bring their expertise to bear on problems, and also to learn what it is to be in a political arena. And there's a lot of cross-fertilization that goes on through that program and through other programs like it.
And maybe another good example, it's Bloomberg, it's an ex-mayor of New York City. He's really involved in such kind of politics in guided the New York City. So it is also a good example for starting this inclusion.
Okay, I see the microphone over there, and then the gentleman here has been trying for some time to get
János Kertész from Central European University. I would like to add to the issue of training. Interdisciplinary education is somewhat suspicious indeed, because it may lead to broad knowledge, but depth is then missing. Nevertheless, we at Central European University have launched a PhD program in network science, as first in Europe and the second in the world. And we try to solve this problem such that we take students with masters, so they have a solid background in one of the disciplines, and on the top of that, they get interdisciplinary training. And in fact, we have already our first cohort. Students have come from finance, sociology, physics, math, and we are very positive and optimistic. And in a few years, I can report about our success. Thank you.
Wonderful. Okay. Now, if you can come down towards this gentleman, and yes. Well,
I am Esko Kilpi from Helsinki. If you would bring into this discussion some insights from sciences of complexity, interaction studies, or even neuroscience, you could claim that context dependence is something that we don't quite get yet. So how would you deal with this possible paradox between computation and contextuality? Thank you.
any thoughts from the panel? Can you elaborate on the question a little bit more, I think?
Well, I see most of the approaches, most of the basic approaches in science to be generic in nature, so they don't really care about contextuality and the nonlinear dynamics of the phenomena that we deal with. And this discussion has been taken up recently in various other fields, but not in computational social science yet. So my question is whether this has perhaps an implication in the future approaches or not. Perhaps it's not applicable.
You're saying that, if I understand correctly, computational social science has been acting independent of context? What do you think of that?
Well, I'm sort of fairly familiar with the complex systems literature because I sort of came out of that world myself. So I actually am not sure I agree with the premise of your question. I think that, if anything, what computational social science is trying to do is precisely, take some of the ideas and methods from complexity science and actually put some context, and by context I mean data, right? So we had a sort of interesting and productive period of what I would sort of refer to as modeling that really was driven by increases in computing power in the 1990s and early 2000s, and lots of sort of stimulating and provocative and counterintuitive ideas came out of that period. But many of these concepts are pretty generic in nature. Sensitive dependence to initial conditions and hysteresis, and these sort of nonlinear concepts are interesting and seem to explain things about the world, but are hard to apply to anything in particular. And I think that really, what has been happening in the last decade is trying to, make the leap from sort of simple models and general intuitions to empirical data and sort of taking on issues of causal inference and context and the things that will help us to solve actual problems rather than just coming up with hypotheses. So I think we are very much trying to head in the direction that you suggest, but it's not easy and it takes time.
Thank you. Next question. I see the microphone, yes.
Hi, my name is Griffith Rees, and I'm also at Oxford. And I guess the thing that I find, I sort of have two questions. One is how emblematic the discussion about journals for papers on social systems is, and the fact that the two people we have here are not from social science journals. And I think in many ways it's actually that the hard science journals are more receptive and engaging about interdisciplinary work into social sciences than actual sociology journals and actual economics journals, which I think is really frustrating and difficult, and just comments that people have on that. The other question is related, say and it's my dim knowledge of the history between, say, economics and physicists. There have been 3 big meetings at the Santa Fe Institute over the last 20 years, something, of physicists and economists trying to interact with each other, and just how difficult that history appears to be. I'm not an economist, so apologies if I'm wrong. But again, it's kind of how this interdisciplinary movements have been difficult in a variety of different ways, not just getting jobs, but actually publishing stuff.
Duncan, do you?
Michael has a paper coming out in AJS very shortly, where he's using mathematical modeling to make the point that survey results can generate biased answers if you ignore processes of influence and homophily. I think Damon Centola has a paper that just came out in AJS using mathematical models to understand cross-cutting social dimensions a la Blau. So I think that that you see signs of change even in sort of fairly traditional sociology journals. Matt can probably speak to the economics world. It's a tough nut to crack. But I don't think your point is misplaced. I think that there are long-standing reservations in the social sciences about agent-based modeling and sort of non-representative, non-random samples of data, and I think that there are there is resistance to novelty, and so I think a lot of what we've seen over the last 15 years or so of these new ideas permeating into the social sciences is actually through journals like Nature and Science and PNAS and even computer science conferences that are then subsequently read by social scientists and often embraced by them. So I don't know, you just have to sort of do it however you can do it, you know, send your work to AJS by all means. If that doesn't work, you know, try somewhere else. It's sort of, you know, it's sort of, I think we just have to do it by hook or by crook.
Okay.
Actually,
I don't see where the microphones are now.
So I have a microphone.
Gentleman here has a microphone, and can the person in the third row and then the second row have been trying to? Yes, so please.
Okay, so I'm Pablo Jensen from Complex System Institute in Lyon in France. I had one short comment and a question. I was struck by the difference, let's say, between the European and the American or Anglo-Saxon view of this big data avalanche, let's say. Because in Europe, we are most focused on the dangers and Snowden and the ethics and etc. And it's, I would say it's not really the focus of all the seminars or the talks that we have been seeing. And we are really, I mean, we are more in America than in Europe here, I think, in this room, and that's okay. And so the question is, as Duncan Watts said just before, I mean, I think that we need infrastructure and we need money and public support to build, let's say, public Facebook, like, I mean, to get data, etc. So, as you said, we need also examples and breakthroughs saying that thanks to big data, I mean, this big social data, we have learned things that we didn't know before, but important things, okay? And not just that the social world is not random, because very often we compare our results to randomness, and this, of course, I mean, social science had already shown that the social world is not random. So what would you tell to a public officer, or, I mean, to convince that really there have been important results that we got thanks to big data? And maybe the panel can answer, but maybe we can also have suggestions by Twitter with the hashtag by the conference also. And these are welcome as examples. We need those examples, I think, in many, many situations.
Any comments from the panel?
I guess, I mean, so at Facebook, and I think a lot of the Twitter research too has focused on examining phenomenon that are happening in social media, which I think is like of great practical importance. So for example, with Twitter, a lot of people studied the various revolutions happening. With Facebook, Bogdan and I had a paper earlier this year about the diffusion of support for marriage equality. A couple of million people changed their profile pictures to an equal sign. And you could say, well, maybe that has not big consequence, but you know, we think differently. So at least in that respect, like treating these new platforms as a new way of interacting and understanding those, I think, is important in and of itself, in addition to other insights that are generated.
I think if you look through the abstracts of the talks at this conference, you could come up with a list of pretty interesting results that we didn't know 10 or 15 years ago that are derived from these new capabilities. And so if your sort of hypothesized audience is not persuaded by those results, then that's a problem, right? Maybe they say, okay, well, I don't care about any of those things. But I think, then you have a bit of a chicken and egg problem where unless you build the infrastructure, we're not going to be able to answer the questions that they personally care about the most. If they can't be persuaded to build the infrastructure until they get the answer to those questions, then we're in a little bit of a quandary. So I think at some point, I think we're pretty close to the point of being able to say, look, this is not joking anymore. Like, this is serious. We're able to do really rigorous, interesting work here. And yes, we are still not able to answer the questions that might be of most interest to policymakers and to even to people in the business world. But you can sort of see how we could get there if only we had the following, if we could fill in the gaps in terms of getting the right data. So that would be how I would make the argument, and I think that's maybe the best that we can do.
I mean, I would add that there's so many use cases. How do markets reach equilibrium? You have now data that you can actually, godlike data, you can look down and see all the buyers and sellers, their bid and ask prices, how the goods clear, or how do pathogens or ideas spread on large scale. I mean, Rogers' landmark work just made the well-mixed assumption. And partly it was methodological, and partly they didn't have data that had network structure, for example. I mean, I think there are very many deep questions, or the origins of norms and culture. In fact, where does culture reside, or where does it come from? How is it sustained? I mean, these are all very deep, fundamental, ongoing, yes, long-term questions. But I think that there are ways in which many scientists across many disciplines represented in this room are making dramatic progress in understanding these deep questions. So I'm actually extremely optimistic about what we can do, and I don't think it's trivial. Not to say that you were suggesting that, but I do think there are ways in which, but I agree with you that there are ways in which we can make our case better. And I think this also goes back to Duncan's now increasingly famous book on Everything is Obvious. I think there are ways in which we can frame what it is that we do as being scientifically profound, but also commercially and in terms of policy relevant. And I think that is our responsibility to do that.
Yeah, and I just want to say, being on that side of the things as a program officer, I have found that most of the people who are sort of at the higher levels in these funding environments are traditional scientists. And when you present something on Twitter data, I mean, there's a lot of skepticism about what that means, and think about talking to your parents or your grandparents on, what if those are meaningful data, and what is the, if the outcome is the adoption of an app, I mean, what does that mean for society? And so to do, I think what Nicholas said is just the translation for those people and saying, talking about the big ideas and selling the theoretical or the mechanismic process that you're actually measuring, and then saying, by the way, we're using Twitter data, we can actually have causal inference using big data. And so I think just that there's a lot of skepticism still about what social media data is for a lot of the bigger funding agencies.
I would add to that policymakers are concerned with very large questions that are facing society. Climate change, should vaccines be mandatory? Questions where it's very crucial to understand how the population and how individuals make decisions, what influences their decisions. And this is something that computational social science is intimately involved with. At this meeting, I saw a poster on echo chambers and the effect on decisions about climate change. There are any one of a number of papers that I could bring to bear on that. And that's something that policymakers really need to get a better grip on, so that they know how the public is going to move.
I mean, inequality, revolution, pro-social norms. I mean, they're just endless important topics that are being engaged, I think, with the data that are increasingly available.
And I would just add that, as a society, it's sort of unproblematic that, if we want to make fundamental advances in physics or in biomedicine, we invest considerable resources in building laboratories and infrastructure and instruments, sometimes billion-dollar instruments, and that is something that we sort of take for granted. Whereas in the social sciences, we have these sort of traditional forms of authority and ways of making decisions that are inherently unscientific. And so when a social scientist comes along and says, we can actually do this better, there's natural resistance from existing traditional sources of authority. But it's interesting, if you go back to the late 18th century, very similar resistance was faced by astronomers who were building the first large telescopes and looking out into deep space for the first time. And there was a lot of public excitement, and people thought it was very cool, but there was a lot of pushback. And the religious authorities, humanities poets were very upset about Isaac Newton. They thought he was really ripping the wonder from the world. And so there was sort of an interesting kind of a parallel public debate about whether science should be invading into these regimes that had been dominated by other forms of authority. So I sort of think we've seen this movie before, and science sort of won mostly the last time around. So we have some hope that if we sort of continue to focus on data and empiricism and systematic application of the scientific method, that we can eventually persuade enough of the public that this is the right way to do things, that we can get the support that we need.
Can I just add a couple things? So I just want to go off on second what Duncan said and then go off on a slight related tangent. I want to second what he said. I think this distinction we have between the natural and the social sciences, we've inherited from medieval theology that sees sort of humans as a part separate from the rest of nature. And I fantasize and hope that that's breaking down. I don't think we really need to see the natural and the social sciences as being so distinct. And I think the natural sciences often have problems. I mean, selling billion-dollar telescopes to the public is not easy. I mean, even people I know say, why do we need to invest in particle accelerators, right? They say, that's just a waste of billions of dollars. We have better uses for the money. So I think those guys also have cases to make, and I don't think that just applies to us. First point. Second point of two I'll make is I think, and no one's talked about the replication crisis, what's fascinating to me is the way in the social sciences we pull our hair out as if replication issues are somehow special to us, but they're not. I mean, the BICEP2 experiment was a big issue in physics. Stem cell biology has had its replication problems, economics, psychology, political science. I mean, there are many, many disciplines which have this issue of replication. And I think it reflects, again, the kind of sense in which we think that social sciences are somehow different than the other sciences. But really, these are generic issues, whether they're advocating for funding, whether it's common instrumentation, whether it's an issue of replication, privacy, availability of data. All of these topics aren't unique to us. And there's this way in which, in a kind of parochial way, we think that, oh, because we're facing the problem, it's only our problem. And I think if we were to step back and have a vision of science that's broader and inclusive, we would see how is our problem similar to the problems faced in other disciplines.
Yes.
Tahir Seri from University of Oxford. My question is mainly for Lada and Duncan, who both have worked in academia and in industry. As a young scientist, I'd like to know what are the main differences between working at a university or at a company. I'm guessing there is a big difference in the pay slip, but how about things related to conflict of interest or intellectual freedom? How should I deal with those things if I've worked at a company like Facebook or Microsoft? Thank you.
I want to hear about the pay slip.
Yeah.
You wouldn't do it for the money, Nicholas.
Maybe that's a little bit more of a coffee break question. I don't know. I mean, it's very different. So with Facebook, and I think it's a little bit different at Microsoft, it's no one's main job to do academic research, right? You're there and you're primarily product oriented, and then because a lot of us are passionate about science, we also do science and are generally supported, but not to the extent that we make that our primary focus. But I think really the two are night and day, and but I think the main thing is, can you get to the research that you're passionate about done? And sometimes the best thing is to go to academia and to do it there. For me, I was always interested in information diffusion in social networks, and so I'm very happy where I am.
I think it's important to realize that there is really a sort of spectrum of industry research, from sort of I think if you go or if you're a data scientist at Amazon, it's probably very interesting, and it's an impressive company. But it's a black hole as far as publications is concerned. I don't think we know anything about what people are doing inside of Amazon. And then you go to a place like Google where they publish things, but it never seems to be the things that are most relevant. They publish papers on radio astronomy and not on search. So there's lots of very, very smart researchers working in Google. I know some of them, and they're working on really fascinating things. But if publication is really what you're concerned about, it's maybe not not for you. Facebook is more open. Microsoft Research is a little bit of a special case because it's almost exactly like working in a university department, except you don't have to teach or write grant proposals. So I think that's sort of and I wish we could hire more people, but so I think that you have to sort of look specifically at the place that you're considering and ask, what additional freedoms will I have there? What additional constraints will I have there? And as any of the faculty members here will tell you, it's not all peaches and creams in a university department either. That there's a lot of stuff that you have to do that is not necessarily what you imagined you'd be doing when you signed up for it. So everything has got its problems, and everything has its advantages. And I think it's probably unhelpful to make these kind of sweeping divisions or sweeping generalizations about either this or that. Everything should be considered on its own merits.
Hello, my name is Hye-jin Yoon from Oxford as well. So one thing I'm wondering is that the way the science is imposed, like the questioned. So the things I'm worried about is the availability of the data may drive the way the science is questioned. So one of the things I'm concerned about, I mean, it's great that we have a lot of interesting data and we analyze the things in a way that never have been done, and the questions arise from them. So it's great. But on the other hand, I'm a physicist so I'm a kind of guilty of charge that some of my friends, sociologists, told me that, economists as well, told me that, you guys are it's great, but on the other hand, these are the things that the questions that you're asking or answering are not quite interesting in my field. So that kind of conversation, happened over and over, and I realized I don't know, so one thing, the physicists are in the guilty of the charge that some people say we develop a hammer, and we are looking for the nails to stamp. So how you think about it? And I know you guys are from great research, doing great research and asking the great questions, but how you deal with such things and how we can avoid things like that?
While the rest of the panel is thinking, let me jump into that particular one, because I see two different sides of that. On the one hand, sometimes the technology in one field is just not available for a while to another field. And it may seem as if the second field is reinventing the wheel. I would say that molecular biology, for example, in plants, took a while to catch up to molecular biology in other easier organisms to deal with, like yeast. Taking an example from molecular biology. And it was still very interesting because plants are crucial. Agriculture, there was a lot that we need to understand. It didn't matter that things had been done in other organisms. The other side of that coin, and something that occasionally I see, is that people from one field will say, okay, I've got my hammer, and I can walk into any field, and I'll start hitting things, and it's going to be great. And sometimes they don't really take the time to absorb the literature in that field. And when something is sent out for review, then there are comments saying, well, yes, but you're ignoring, a few decades of research that have gone on in this field that are leading us in a different direction, or that you need to consider as you build your hypotheses. So it is a challenge, but sometimes that cross-fertilization can lead to really fantastic insights. So there isn't an easy answer to what you've asked, but it's a question of trying to look at both sides. Patrick, did you have anything to add on that?
I suppose it sort of occurred to me, you were talking about how the problem with data leading the questions that are being asked. I mean, and it goes back to what Nicholas was saying about thinking that the problems are specific to this field. I don't think that's a problem that's specific to computational social science. I think, biology, you ask questions in model organisms because that's where the data is available. Here, your model organisms, I guess, are Facebook and Google and Twitter. It's just they're not Drosophila and E. coli. So yes, it's a problem, but it's a problem for all of science.
I would maybe just add that I think no good data should go to waste, so don't feel bad about studying what's out there. Usually, at the very least, you'll have a good time and probably also contribute something to science. And as a physicist myself, I've worried about this, kind of the physicists barging in. I think Duncan calls us a pack of hungry wolves or something like that, invading other fields, and how we really shouldn't do that. But I think there's a benefit because people have been thinking in one way or, going on a certain track for 20 years or something like that. And if the physicist goes and reads all that literature, they might end up on that track as well. And they're probably going to come in, they're going to stir things up, they'll probably get it all wrong. But at worst, maybe they'll anger people in that field enough so that they rethink things and maybe, shake things up a bit. So I also think there's no harm in physicists making fools of themselves going into other disciplines.
And one aspect of the solution to this is just having good interdisciplinary work. And so one of some of the wisdom that has come out of funding interdisciplinary work is that the best projects come out of situations where the postdocs are given the authority or the goal to interact with the other labs. So it's the groups that have the more junior people who are interacting who do better interdisciplinary work. So that's maybe something that comes out of just being less sort of siloed in thinking about these kinds of problems, and their hammers are not as developed at that stage. So.
I see one final question, and then Santo is gesturing at me that coffee is calling us.
Oh,
so.
I wasn't sure what time you ended. But the Barbarassi talk showed us wonderful citation patterns leading to Nobel Prizes at the end. In this area, I don't know, the question is, will there be a Nobel Prize in this area? What one will it be? And who's going to get it? So I suggest two to be, like Stuart Kauffman and Chris Langton sort of gave birth to a lot. Do they have any creds with you guys?
Crystal ball, anyone?
I think that's a coffee time conversation. Maybe a bar.
I also think that that's a lovely ending point. Let me thank all of the panelists, and again, thank you all. Lovely.